This video briefly introduces omnidirectional dual-polarized antenna, using co-located slots with Wedgy profile. This work proposes a wedge-profiled antenna with both considerations of electromagnetic and aerodynamic performances for supersonic onboard systems. This work was finished by Professor Yulis Group from Tsinghua University. More details can be found in the homepage or group WeChat. In the fighter systems, many types of antennas are installed on the fuselage for multiple functions. To reduce windage, the antennas are usually low-profiled. However, with the development of the fighter, the antennas are required with higher performances. For example, omnidirectional radiation for full azimuthal coverage, and dual polarizations to avoid polarization mismatching. To achieve these performances, the antennas occupy more space and enlarge the windage. So, it remains a challenge to realize an antenna with both low windage and high performance. The key point to solve this problem is the profile. For example, the antenna can be designed with wider bandwidth, if occupying a larger profile. Besides, different antenna profiles will result in different values of windage. Hence, both electromagnetic and aerodynamic performances are limited by the antenna profile. Based on the aerodynamic analysis, it can be observed that the case of wedge profile has the smallest windage coefficient, and the smaller angle of wedge will result in lower windage coefficient. So, a wedge is selected as the main profile of the antenna. In this work, based on this Wedgy profile, a metal cavity is designed with co-located slot structure. For horizontal polarization, two identical half-wavelength slots are etched onto the cavity sidewalls symmetrically. Meanwhile, a folded slot is carved horizontally for vertical polarization. These two modes of dual polarizations are orthogonal, so the antenna achieves a high port isolation in such a compact Wedgy profile. As seen from the experimental results, the port isolation between dual polarizations is higher than 42 dB in the overall operating frequency band. Besides, the antenna also achieves omnidirectional radiation for both dual polarizations. Compared with the other omnidirectional dual-polarized antennas, the proposed antenna occupies similar space, but realizes a very small windage. It proves that using a Wedgy profile is the better design for the supersonic fighter. In a whole, a wedge-profiled antenna is proposed within a compact volume. For low-windage supersonic onboard systems, the co-located slot structure within the Wedgy profile realizes a high port isolation and omnidirectional radiation for both dual polarizations. More essential, this work proposes an approach to design the antenna, with the collaborative considerations of both electromagnetic and aerodynamic performances. More details about this work can be found in the
Thanks for the invitation from IEEE APS. Today we will talk about our paper, Low-Profile Dual-Polarized Multi-Beam Antenna based on Pillbox Reflector and the 3D printed rigid waveguide. The proposed antenna is composed of two Pillbox beamforming networks, HP and VP SWA arrays, and two PPW to RW transitions. The operating principle of the antenna can be described as follows. The different input ports of the Pillbox beamforming networks can generate the planar waves with different propagation directions, which can generate different phase gradients to the radiator array and steer the main beam direction. The Pillbox reflector can be regarded as a blend PPW with the outline of a parabolic line. The folded structure of the Pillbox beamforming network makes it can achieve the Python beam scaling capability. However, since that the PPW of the Pillbox beamforming network and the RGW of the radiator array has different fundamental modes, we have to realize the modal transitions. First, the RGW are gradually changed to the waveguides, then a two-order waveguide impedance transitions is used to match the impedance of the PPW and the waveguides. For the radiator design, two main parts are an HP SWA part below and a VP SWA part above. Both the HP and VP SWA can achieve the wide beam width with low cross-polarization. The fabricated antenna phototype is present in the left figures of this page. The antenna can achieve the overprinting bandwidth of 9.9 to 10.1 GHz, and the resolution is below -13 dB. The radiation pattern shows that the proposed antenna can achieve the ±36-degree beam scaling in the multi-beam line, with a minimal crossover level of -2.1 dB. The cross polarizations are below -15.9 dB. In summary, the novelty of this work included that the application of the RGW greatly decreased the distance between the HP and VP SWA units. The metallized 3D printed technology makes it possible to construct the complex SWA array. The PPW to RGWS transitions solve the mode and the impedance matching problem. The advantages of dual polarization, high aperture efficiency, low cross polarization, wide beam scaling range, and low crossover level make the antenna design is a very appropriate choice in multi-beam radars and communication systems. Thank you.
In this video, we briefly introduced our work named a plus and -45-degree polarized antenna system with 4 isolated channels for in-band full-duplex IBFD. The further details can be found in IEEE transactions on antennas and propagation. In-band full-duplex IBFD, which features in simultaneously transmitting TX and receiving RX signals and can theoretically double the spectrum efficiency compared to traditional half-duplex systems, thus alleviating spectral congestion. However, the self-interference SI receiver and transmitter can be anywhere between 90 to 120 dB more powerful than the signal of interest. As the first defense against SI cancellation techniques in antenna and propagation domain is important. In a 4-channel IBFD system that allows simultaneous transmission in 2 orthogonal polarizations, 3 types of coupling need to be simultaneously addressed, which is more challenging than that in a 2-channel system. In this work, a multifunctional isolation feed network is firstly proposed, which consists of feeding the antenna differentially, combining the horizontal and vertical polarization into plus or minus 45 degrees polarizations, and canceling out unwanted reflecting and coupling signals. Then, by the decoupling structures, 3 types of coupling are simultaneously addressed without deterioration to each other, which enables a 4-channel IBFD system with plus and minus 45 degrees polarizations for both TX and RX. The antenna system is simulated, fabricated and measured. It can cover the bandwidth of 3.3 to 3.9 GHz, with the isolation of 39 dB between any 2 ports. Besides, the gains of all ports are more than 6.2 dBi, with the maximum gain of 8.6 dBi. The radiation patterns of all ports are consistent and stable. The results exhibited an excellent candidate for 5G sub-6 GHz IBFD applications. More details can be found in the reference. Thanks for your listening.